Hi everyone, in this video we are going to cover how you can graph a linear equation, so graph a line when you're given x and y intercepts, as well as how to find those x and y intercepts when you're given an equation in standard form. So first, let's refresh our memory on some vocab. What exactly an x and a y-intercept are? Well, an x-intercept is an ordered pair that intercepts, so like if we think about football, you throw an interception, it lies on that x-axis. It's intercepting with your x-axis. So your x-intercept is any point that falls on the x-axis. It's intercepting that. In order for a point to be an x-intercept, in order for it to fall on that line, that means that our ordered pair will always be as such. We have a value for x, but then 0 is always going to be your y value, because that's honestly the definition. That's what makes it an x-intercept, because you're going 0, you're going nowhere along your y. You're not going up or down at all. You're flat right there on the x-intercept. Then for your y-intercept, it's very similar, only that is an ordered pair that intercepts with, that lies on your y-axis. Very similar in regards to your ordered pair. In order for it to be a y-intercept, your x value will always be 0, and then your y value will be a certain number, because you are going nowhere along the x, you are only moving along that y-axis. That is what a true definition is for that x and the y-intercept. And this is going to come in handy in just a moment. But before it does, let's practice graphing a line given x and y-intercepts, because in order for us to graph a line, we need a minimum of 2 points. 2 points creates a line. Now we are asked to graph a line that goes to the points -5, 0 and 0, 7. First, let's identify which one of these is our x-intercept and which one is our y. Because with them being zeros, it can be very easy to mix up. Remember, with ordered pairs, your x value is first, and then your y value is second. That is different from slope. So we got to make sure we have that down pat. When we're talking about ordered pairs, your x value comes first and then your y. That means this very first point here is going to be an x-intercept, because we are going -5 along the x-axis and then 0 nowhere for our y. When we graph that, it is right here. So we go over -5 on the x-axis, nowhere on the y. It's on my x-axis, meaning it is an x-intercept. If we look at our second point here, 0, 7, that would be our y-intercept, because we are going nowhere along the x and we are only moving 7 y. So we start at the origin, we go nowhere along the x-axis, but we do go up 7. There is our y-intercept. Now that we have those 2 points, we can draw the line. It is important when we draw that line that we make sure it's a line and not a line segment. Let me show you the difference. This right here would be a line segment, because we have 2 endpoints. But we are being asked to graph a line, which means it goes through these 2 points. There are a ton of other points, a ton of other solutions on that line. These just happen to be the intercepts. So we need to make sure that line continues, and we put an arrow on both ends to show that it continues going in both directions. All right, let's try one more of those real quick. This time we want to graph a line that goes to the points 0, -3, and 9, 0. So first things first, make sure that we remember with an ordered pair, what comes first? Your x, and then your y. That is the proper order for an ordered pair. If we look at our very first one, oops, I did my colors backwards. Let me fix that. I want to make sure my color coding is the same. So if you guys are taking notes and using colored pencils, it will match. So X is blue and then the y-intercept is red. All right. If we look at that first ordered pair, 0, -3, what do you think? Is that going to be an x-intercept or a y-intercept? That's going to be a y-intercept because our x value is 0. We go nowhere along the x, and we just move -3 along the y. If you wanted to, you could graph it real quick just to make sure you're not wrong before you jot that down. We start at the origin, nowhere for my x, down -3 for my y. Yep, that intercepts, that crosses the y-axis. It is our y-intercept. Okay, second point, 9, 0. Is that our x-intercept? It is. We start at the origin, we go over 9 on our x, nowhere on our y, which lands it right there on the x-axis. That is our x-intercept. Once again, I'm not done because my directions told me to graph a line, meaning we need to connect those 2 points with a line. Obviously, it may not be perfect. I don't have a ruler, but that is okay. That's what the points are for. All right, not too bad, right? But what do we do if they give us an equation and ask us to find the x and y-intercepts in order to graph? Well, first things first, if we think back to what we learned earlier, when we have linear equations, there are 3 different forms. This form right here is called standard form. That's when we have our x term, our y term is equal to a constant. That is considered standard form. So if we write out what standard form is, just for funsies, little extra knowledge, that's ax plus by equals c, where a and b are a coefficient. So that's the name for the number in front of your variable. And then it's equal to c, our constant. All right, just that little fun background information. Now let's get to it. If you think back to the very beginning of this video, we really emphasize that if you have an x-intercept, in order for it to be on the x-axis, that means you have a value for x, and then your y is going to be 0. That's what causes it to be an x-intercept. That's what causes it not to move somewhere else and stay on the x-axis. Therefore, if we want to find the x-intercept of this line, we know that 0 will be our y value. So if we substitute, if we plug in 0 for y, that will allow us to solve our equation for x, and it will give us our x value when y is 0. And when y is 0, we have our x-intercept. All right, let's break this down. And as you can see here, I do have steps. So our first step is if we're trying to find the x-intercept, we are going to substitute 0 in for the y value, because I know for an x-intercept, 0 is my y. I may be repeating that a lot, but I'm really hoping that you guys will understand the reason behind it. All right, so 3x minus 0, because we're substituting, so we're replacing y with 0 equals 9. Step 2 just tells us to solve that equation for x. Let's solve and find our x value. Well, do I really need to write 3x minus 0? No, because 3x minus 0, I mean, one, they're not like terms, but even if they were, if you subtract 0, it doesn't change it any. So let's write that as 3x equals 9. What do we need to do to get x by itself? Divide. That means our x value is 3. So when y is 0, our x is 3. This gives us our x-intercept because we know and we are saying, hey, y is 0. When that happens, your x value is 3. And looky there, there's your x-intercept. Now, very similar fashion, when we want to find our y-intercept, only the reverse is true. To find a y-intercept, your x value is 0. You go nowhere along the x-axis. So what do you think we're going to substitute 0 in for this time? we're going to substitute it in for our x value. Because we're saying, all right, when x is 0, it's going to give us a y-intercept. So when x is 0, what is my y? So instead of 3x, which is 3 times x, we have 3 times 0 minus y equals 9. Once you substitute, step 2 is to solve. Let's solve for y. We want to simplify any equation first. I see multiplication right there. 3 times 0 is 0. Leaves us with negative y equals 9. Now we want to solve for y, meaning positive y. So are we done? No. What is that negative really? It's really a negative 1. So we have negative 1 times y equals 9. The inverse of multiplication is division. We'll divide both sides by negative 1. Y is equal to negative 9. So y is equal to negative 9 when your x is 0. And when our x is 0, it's a y-intercept. So we have our ordered pair. All right, just to prove that we can, then you could graph this, all right? So right there, we have proven because our x and our y values are equal to 0. We're actually going to take a brief moment though and triple check. We're going to triple prove it. We are going to graph this equation on an actual graph so we can see if it really does go through those 2 points. Okay, so here I am on a free graphing website called Desmos, and we are going to type in the equation 3x minus y equals 9 and see if it has, oopsies, I can't type today, those intercepts. We said our intercepts were what? Do you guys remember? Zoom out here. Our x-intercept we said was 3, looky there, and our y-intercept was negative 9. Bingo. Okay. So even though we have this ability here to graph this equation, you're not always going to have a graph, nor will you always be able to use this graphing software. So let's go ahead and go back and solve one more problem together so you guys can see another example. I just wanted to prove that when you graph it, it really does work. Okay. Let's try this second example. Once again, we are asked to find the x and y intercepts given the equation of the line 3x minus 5y equals 15. Let's start with our x-intercept first. So with our x-intercept, remember the definition, what makes it an x-intercept is that your y value is and always will be 0. That is why we can substitute 0 in for our y value, because we're like, all right, if I know y is going to be 0, what does x have to be to make this equation true? So we're going to substitute that in. 3x, instead of minus 5 times y, it's minus 5 times 0 equals 15. Step 2 is to solve. So remember that unit 2, remember how to solve an equation. So first we need to simplify. Negative 5 times 0 is 0. We're left with 3x equals 15. 3 times x, the inverse of multiplication is division. 15 divided by 3 is 5, meaning when y is 0, our x value is 5. And that right there makes our beautiful x-intercept. That makes our ordered pair 5, 0. For our y-intercept, that definition, what makes it a y-intercept is your x value is 0. That's what keeps it on the x-axis. So we're going to substitute 0 now in for x. Instead of 3 times x, we have 3 times 0 minus 5y equals 15. Simplify your equation. 3 times 0 is 0. Make sure you don't lose that minus or that negative sign, okay? Because the sign in front, or another way to say that, to the left of a number, it belongs to it. So that -5 is really a -5. It's just a synonym, okay? Kind of like in English, you can say run or ran or running. Different forms, all means the same thing. -5y equals 15. Divide by -5. Y equals -3. So when x is 0, our y value is -3, making that our ordered pair, making that our y-intercept. All right, guys, thank you so much for taking the time to watch this. I hope this helps and clears up any questions you may have had. As always, if you need anything, send me an email or come to a help session. Bye.